Hey everybody, welcome to the Muscle Intelligence Podcast. I'm your host, Ben Pakulski, bringing you intelligence for your body, mind, and your soul. Today's podcast is another epic conversation with Dr. Benjamin Bikman, professor of metabolism from Brigham Young University. We're diving into fat, carbs, proteins, everything you're going to want to understand to optimize your body and ultimately live a greatest life in a body you love. Dr. Bikman goes deep into insulin and understanding why we get sick, insulin's role in illness and disease across the board. We talk a lot about the metabolic differences between fats and carbs, and how ultimately controlling your insulin and controlling your inflammation may be the key to optimizing health. We talk about metabolic flexibility, how to get your body to be able to adapt between fuels, fat or carb. A lot of people become metabolically inflexible due to excessive amounts of carbohydrate intake, excessive amounts of inflammation. Dr. Benjamin Bikman is going to tell us how to optimize it. Dr. Bikman is the author of a soon-to-be-released book called Why We Get Sick. And after listening to this podcast, you're going to know why you should go out and get it. He's an absolute wealth of information. He's great on Instagram. He's giving you 30 to 67-second nuggets almost every day on how you can really understand metabolism and apply it to your life. And he's someone who, one of the very few people, believe it or not, that I actually watch on social media because he's always giving incredibly valuable information in a really, really easy to consume format, which I think is just incredibly valuable. Dr. Bikman talks a little bit about other types of proteins, plant proteins as compared to animal proteins, and other interesting things related to BMI and how that may be, as most of us know by now, an extremely outdated measure of health. Without further ado, I'm going to bring you this podcast with Dr. Benjamin Bikman that is brought to you today by Blue Box. Our amazing friends at Blue Box continue to sponsor our podcast, continue to provide an amazing product that I'm literally sitting here wearing right now in front of my computer. I spend a lot of time with my computer, and especially during this quarantine stuff, there's additional time in front of screens, in front of computers, in front of cell phones and television. And you'll notice if you ever watch me on YouTube, if I'm not wearing my glasses during the podcast, I'm blinking a lot. And since I've started noticing that, I put my Blue Blocks back on, and then my eyes feel like they're getting stronger again. They were just so tired all the time. And I'm sure that's negatively impacting my ability to see and focus. So for someone who ever has issues with focus or being tired or feeling like your eyes are tired, I highly suggest you slap on a pair of Blue Blocks either while you're working at a computer or anytime after the sun goes down. If you're exposed to any type of artificial light, slap on a pair of red ones like I do and reap the benefits of improving your sleep and helping your eyes and ultimately your autonomic nervous system and brain calm down. You can head over to blueblocks.com/muscleintelligence, BLUBLOX.com/muscleintelligence, and use the code MUSCLE to get 15% off my favorite blue blocking glasses. Actually, there's one more thing that you should get from them because it's amazing. They have a sleep mask, and it's really, really thick and really, really soft and is awesome. I love it. Huge fan. My son, ironically, has actually been using it while he sleeps. He looks really cute. I posted a picture on Instagram recently. He loves it. I love it. And it really helps to block out all the light while you are sleeping. And it feels really good. It's nice and soft. It doesn't dig into your head like some of the other ones. Again, shout out to Blue Box, and I hope you enjoy this podcast with Dr. Benjamin Bikman. Hey everybody, welcome to the Muscle Intelligence Live podcast today. I'm extremely excited and grateful to introduce Dr. Benjamin Bikman, who I'm a massive fan of, been a guest in the podcast before. Man, honestly, you're one of the few people on Instagram I actually watch because you have these amazing 30-second snippets that are super, super short and super actionable. And honestly, that's the type of stuff that I like. It's like you're giving so much value in these really short clips. And, man, I know you've got so much more than that to offer, so I'm super grateful to have you here.
Oh, my pleasure, Ben. Thanks again. We had a great time the first round when we were talking together on the podcast before, and I'm thrilled to be doing it again.
Yeah, absolutely. And so one of my greatest areas of fascination is where you focus, is metabolism, understanding all of these things that are impacting how your body tends to utilize energy. And I think most people seem to not understand it all that well, which is why I think this will be an extremely valuable podcast. But I'd love to have you just kind of tell us what you do. Like, obviously, you're a professor of, I don't even want to put words in your mouth, so I'll let you introduce yourself.
Yeah, there's too many words.
Yeah.
I'm a professor of pathophysiology. I say it that way just because that's the actual class I teach. And pathophysiology is the sick body, or it really takes students to the next level where they've had physiology, which is how the body systems interact with one another, or just work. And then pathophysiology is when they're not working well. And that plays into my strengths because my academic background and now scientific career is to study insulin resistance. And that was an interest that kind of started to blossom during the course of my PhD studies. But I don't want to get ahead of myself. Very briefly, I'd started my academic career in the realm of exercise physiology, actually. That was my master's degree. And at the time, I was interested in how the muscles adapt to a stimulus. What is it in the body, in a bigger sense, that helps the body get better when it's exercising? How is it adapting? And before I knew it, by the time I got to the end of my master's thesis, I was less interested in exercise and how the body's adapting to exercise. And I was becoming much more interested in how the body adapts to weight gain, how the body adapts to obesity. And during the course of my doctoral dissertation studies, I really started looking more and more at insulin and insulin resistance. And I didn't even know at the time just how relevant that was to chronic disease, but it really has allowed me in my undergraduate class that I teach, these 150 future medical practitioners, nurses, doctors, PAs, PTs, et cetera. Every semester, I get to sort of instill in them part of some of my perspective, which is that almost every chronic disease has a lifestyle component to it. And then that lifestyle component is generally going to, in some way, influence insulin resistance. And so, in essence, if we link that together, insulin resistance is at the heart of virtually every chronic disease, non-infectious chronic disease. And people would be shocked at just how relevant that is. But it is relevant, and it is enlightening, because when you appreciate that most chronic disease is built on one single foundation, well, then don't try to address the chronic diseases out here that are sort of branches of the tree. Don't worry about a medication for your blood pressure, a medication for your diabetes, a medication for your infertility. All of those and many, many more actually can be better addressed by going right to the cause, right to the root. And that is empowering, because the best way to address insulin resistance is not any medication. It is entirely altered by lifestyle. Lifestyle is the culprit or the cure.
So interesting. So now when most people hear insulin resistance, their brains automatically go to carbohydrates, I assume. And I know that's one piece of it, but I'd love for you to maybe start taking us down the path of all of the things that could potentially be contributing to insulin resistance. And starting from maybe a genetic level, like, is there known genetic predispositions or advantages on the other end? Conversely, maybe is the lifestyle factors, maybe inflammation, maybe gut health, like, are all those things in some way contributing to insulin resistance?
Yeah, they sure are. Without a doubt, genetics is a contributor. We can see the most extreme version of insulin resistance is full-blown type 2 diabetes, and that is actually more genetic than type 1 diabetes. It's much more common. You see this inheritance or generational pattern of type 2 diabetes than you see with type 1. So yes, there's a genetic component to it, but we can't do anything about that. And so I don't like to really focus on that. It just means someone's going to have to work a little harder or not as hard on the lifestyle component. And with regards to the environment that we put ourselves in, or in other words, the lifestyle component to it, one of the biggest causes of insulin resistance is insulin itself. And that might seem a little counterintuitive at first, but it really is just reflective of a fundamental biological principle, where in the human body, too much of something will cause a resistance to that something. And we see this across not only hormones, but even substances that we put in our bodies. A little bit of nicotine used to give a person a certain type of high. Well, it doesn't anymore. They need more nicotine to get to that same level they were before. Or alcohol or caffeine, doesn't matter what it is. Too much of something will cause a resistance to that something. So if someone is living a life where they are chronically bumping up their insulin, they're bumping it up every 2 hours because they're told to eat high carbohydrate or high sugar snacks, and meals every 2 to 3 hours, they are living basically every waking moment in a state of elevated insulin. Because if you eat a carbohydrate-rich meal, your insulin will be up, depending on the person, for anywhere from 2 to 4 hours. And the way we tell people to eat, we say eat 6 meals a day or whatever, their insulin is going to be elevated every waking moment. And it only starts to come down at the end of sleep in the morning. And of course, they immediately spike their insulin back up with some starchy, sugary cereal or toast or bagel. So insulin itself is a key cause of insulin resistance. And so that does then point the finger at carbohydrate. But as you note, there's more to it. Sleep deprivation can immediately cause insulin resistance. This can be even quantifiably different the next day. One bad night of sleep can cause insulin resistance. Now, of course, that's an acute insulin resistance that one good night of sleep can undo, but it still matters. Stress, so the hormone cortisol, the main stress hormone, and even a secondary, that's not fair to it, another stress hormone, epinephrine, is also an insulin antagonist. So if you're chronically stressed, whether it's an emotional stress or even a physical stress, like overtraining, cortisol and epinephrine are going to be elevated, and they antagonize insulin's effects. And that matters even, Ben, in the context of like the Muscle Intelligence podcast. Even if we look at the level of the muscle, when a muscle becomes insulin resistant, that protective effect of insulin on inhibiting proteolysis or protein breakdown in the muscle is diminished. And in contrast, cortisol, it wants to wage war on muscle. It is directly causing protein breakdown in the muscle. And because it's antagonizing insulin and making the body more insulin resistant, insulin itself is less capable of protecting the muscle because it is one of insulin's main actions. So anyway, so insulin itself, sleep deprivation, stress, and then inflammation, like you note, is also antagonistic towards insulin signaling. And this is relevant in people with autoimmune diseases. So, for example, people who have rheumatoid arthritis, when they are going through an active phase, and this is for any autoimmune disease, it's just been measured in rheumatoid arthritis quite well. During the active phase of the disease, because it kind of ebbs and flows, where the inflammation is high or it kind of diminishes for a while. When it is active, their insulin resistance is worse. And then when the inflammation subsides, insulin sensitivity starts to rebound.
So effectively, it makes sense then that anything that causes a stress response in your body, which could potentially be, and I'll love you to speak to this, certain types of foods that aren't even carbohydrate rich, could be causing some type of level of cortisol response, inflammation, and therefore insulin resistance.
Yeah. So if someone has a food sensitivity to anything, if someone has a food sensitivity towards gluten or towards egg, whatever, although the egg one is tragic just because I consider eggs one of God's most perfectly packaged foods. But whatever the food is, if someone has a genuine sensitivity to it, that will result in an inflammatory response. That is a key part of something like celiac disease, and that inflammation will antagonize insulin.
Yeah, and so how about something like artificial foods, pesticides, things like that? Has anyone ever looked at data around how those are causing inflammatory cascades?
Yeah, what a great question. Not that I know of, no, but it is worth noting that those are a primary part of our diet. Pesticides and chemicals that are not pesticide, but these estrogen-like these estrogen analogs, things like bisphenol A, BPA, or diethylstilbestrol. These are things in plastics and soaps. Like the softer the plastic, so when someone's getting these plastic water bottles from grocery stores, the more squishy that plastic is, the likely higher the content of BPA. Not always, but generally. So these are chemicals that also, when it comes to metabolic function in a general sense, are not optimal.
I asked you this, I think, in a comment on one of your posts, but I wouldn't expect an extensive response. We'll have to ask you now. Is anyone looking at the correlation between carbon dioxide and its impact on metabolism? So there's a guy out there, Brian McKenzie, who's starting to quantify heart rate variability, carbon dioxide, and carbon dioxide tolerance. So your ability to tolerate CO2, as that would be implicated in obviously your body's ability to use more oxygen at the cellular level. Just curious if you've seen anybody kind of start diving into CO2's implication on, whether your body's going to tend to use more fat, aerobic or anaerobic. So I know he's spearheading the research, or trying to, and I'm curious at your level if you've seen anybody. And I know he wasn't able to ask that question accurately or extensively, but I'm curious if you've.
No, I get it. I get it. No, I'm not aware of anyone looking at CO2 tolerance in the context of a fuel shift, but I appreciate the question insofar as the body is a hybrid, really relying on the two primary fuels at varying levels all the time, glucose and fat. Can CO2 tolerance or CO2 levels influence that? I don't know. I suspect the more CO2, I'm totally speculating, I suspect the higher tolerance for CO2 probably would correspond with a higher capacity for fat burning, insofar as fat burning is heavy on the gas exchange, needing a high degree of oxygen. But I will say, so that's the limit of what I know and can speculate there. I actually like that direction of research. I am an advocate of controlled breathing and breath holding in order to promote a greater CO2 tolerance. I use that after I read the book Oxygen Advantage, I think it is. I found it to be quite helpful for me for controlling anxiety and sleep. I'm just naturally I think naturally, at least ever since I was married 20 years ago, it's certainly whatever the switch was, it flipped then. And then once we had kids, it sort of went up a notch again. But I really just have trouble calming down sometimes. I just am kind of a little amped up. And those breath holds have really been helpful. And a lot of that is the longer you can hold your breath, the more tolerant you are to CO2, because CO2 is the main driver for ventilation. We always, we're exercising, we're out running with a friend, and the friend says, hold on a sec, I gotta catch my breath. The implication there is that, I need more oxygen. Not really. You actually are breathing hard because you need to breathe off that CO2. That's the main driver of breathing. So the idea is you increase your tolerance to that and you can control your breath better.
Yeah. So then the offshoot question, like the secondary question to that is there anyone quantifying the relationship between heart rate variability and metabolism, right?
Yeah,
so we would speculate.
It'll be fun to see those data.
Yeah, we would speculate for the listener listening. I mean, I'd love for you to speculate. Like someone in a more parasympathetic state would tend to be more aerobic, therefore a greater amount of fat metabolism. Does that seem to?
Mm-hmm.
Yeah.
Yes, it does. Yeah, because typically fat metabolism is inversely related to intensity. And so if we are engaging in an activity that we can, and you can also bump that up, just like you can increase your CO2 tolerance, you can actually increase the intensity of the activity that is fueled by fat. Typically there's this shift. Yeah, intensity's climbing, and then glucose metabolism climbs with it, and fat metabolism is turned off, because those two are reciprocal. You're not using high amount. Well, you can use high amounts in general, but the predominant fuel will start to shift reciprocally. One goes up and the other one comes down. So as someone is training their body at ever higher intensities, they are enabling the body to have fat fuel that higher intensity for longer. And so they push off that shift towards more heavily relying on glycolysis.
Yeah, that's one of the first kind of approaches I'll take with anyone's transformation, is simply like, let's push your anaerobic threshold up. So we're increasing that VO2, and you're improving recovery, you're improving your body's ability to work at a higher threshold, still staying aerobic. And I think that's a big missing piece in the fitness industry that people aren't paying attention to.
Yes, agreed.
Yeah, one thing I'd love to have you kind of go down the path of is this concept of metabolic flexibility and optimizing fat metabolism. And I know you're, for the most part, I believe, an advocate of ketogenic diet, but I'm curious if it's perpetual ketogenic or a cyclical ketogenic or seasonal ketogenic, and what is, if my aspiration is ideal body composition all the time, ideal brain function, ideal inflammation. How do I get into a ketogenic state fast and stay fat adapted? And two, how often do I need to kind of cycle back into it, or should I be in it all the time?
Yeah, that's a lot right there. That's excellent. So metabolic flexibility is really I want to define it by actually looking at the bad version of it, which is this metabolic inflexibility, because that was how it was first noted by the scientist Brett Goodpaster at University of Pittsburgh and his colleagues. The observation was that people with insulin resistance type 2 diabetes didn't have this fuel shift that we see in people that were non-diabetic, non-insulin resistant. And by that I mean, if you take a healthy person, feed them a meal, glucose burning spikes. So they eat a mixed macronutrient meal. The primary fuel, as they measure fuel use in the body, then becomes glucose burning. After a few hours, as they enter this kind of fasted state, it shifts and glucose burning comes down and fat burning climbs up. That's what we see in the healthy person. In other words, they shift between these fuel uses. Glucose in the fed state, which is what insulin is high, and then I'll come back to that idea in a moment with insulin, and then fat burning in the fasted state. That's a metabolically flexible situation. Inflexibility, metabolically speaking, is when the person, the fed state continues even in a fasted state. And by that I mean they eat a meal, glycolysis predominates, that's the main energy, and then even hours after the meal in the fasted state, glycolysis still predominates. Fat burning doesn't come online. So they are stuck. They are inflexible. They're stuck in sugar burning mode, or blood sugar or glucose. And importantly, insulin dictates that fuel use. If someone is metabolically inflexible, they are insulin resistant, their insulin is chronically elevated, and it is keeping the body stuck in sugar burning. And I mean that. Insulin controls fuel use. If the body is burning fat or burning glucose, it's because of insulin. And that's important because if someone wants to, sorry, I should finish. So insulin's high, the body's sugar burning. If insulin's low, the body's fat burning. And that matters because if someone wants to lose fat, they're going to have a very hard time doing that if they're really stuck in sugar burning mode. So you have to give your body a break from the insulin. Let the insulin come down. And that doesn't have to be a ketogenic diet, although a ketogenic diet is just one of the, I guess, most extreme ways. I don't like to use that word extreme because I don't mean for it to be such a polarizing topic. So I should say it's one of the most dramatic ways of lowering insulin. Of course, the most dramatic is fasting. If you're not eating anything, your insulin has come down. Now, anytime insulin is low for long enough, the body is burning so much fat that it's actually burning more than it needs for its overall energetic needs. And so we start the liver takes some of that fat burning and starts shunting it over into this new pathway of making ketones from the pieces of fat. And that matters because, as we're about to publish this paper, ketones stimulate the fat tissue to behave differently. This is something I've been talking about for 3 years. This has been the longest project I've ever been working on, but it'll be published soon. Ketones stimulate the fat tissue in the body to actually start wasting energy. And so we have this what's called a mitochondrial uncoupling. And we did this in humans. We pulled fat biopsies from humans that were in ketosis or not in ketosis. And we found that the metabolic rate in the fat tissue when someone's in ketosis is about 2 or 3 times higher. And it's just because those mitochondria in the fat tissue are just wasting energy. They're just burning through glucose and fat for no reason. Like, as opposed to the muscle, ketones do nothing. They don't have this phenomenon in the muscle. We published this paper last year. In the muscle, there's perfectly maintained mitochondrial coupling. In other words, the mitochondria in the muscle are only using as much energy as they need to produce ATP, the main form of sort of usable energy in a cell. When the cell needs to get something done, it's typically relying on ATP to do it. So nevertheless, so someone is in ketosis or in a ketogenic state if insulin is low. Fasting and a very low carbohydrate diet can do that. But someone doesn't have to be in ketosis all the time. Now, you mentioned the cyclical ketogenic diet. I think that is definitely the best way to explain my way of eating. Partly because I am a family man and I have it's difficult for me to perfectly control every meal all the time, and I don't want to. Frankly, I like knowing that my adherence to a low carbohydrate diet so diligently allows me to have some indulgence And I can get away with that because I don't have the genetic predisposition for insulin resistance. The more someone has that genetic predisposition for insulin resistance or type 2 diabetes, the more careful they have to be. It is my good luck that I have a little more wiggle room. And maybe I can say that because I've been so diligent for so long. But nevertheless, I'm a father of little kids. It's a busy little family. It's just not too practical for me to maintain a ketogenic diet all the time. So I am definitely cyclical. I think we can scientifically defend that, but I have to speculate because I don't know of research to support this. The upside of a cyclical ketogenic diet where the person has structured in periods of time where carbohydrate consumption is up is that it does maintain glucose tolerance. Now, Ben, at the risk of getting off on a bizarre topic here, and you'll steer me back if I'm going too far, people will commonly say a ketogenic diet causes insulin resistance. That's said. They'll say it in nice ways, saying, well, it causes a physiological insulin resistance. And that is not correct. Insulin resistance, whether it is pathological, which is how I've studied it in the context of disease, or whether the insulin resistance is physiological, like with pregnancy and puberty, those are the two times when the body just naturally becomes insulin resistant to fuel growth in the person or their future baby. In those instances, insulin is high and the insulin isn't working as well as it was before. And those are the two fundamental aspects of insulin resistance. Insulin is elevated and insulin isn't working well. What we see in someone who's adhering to a long-term to a ketogenic diet is their insulin is exquisitely low. And if we put insulin in the body, if we were to give that person an injection of insulin, it's going to work exceptionally well. So that is not insulin resistance. A ketogenic diet long-term can create a glucose intolerance. So if someone's adhering to a ketogenic diet and then they load their system with glucose unexpectedly after weeks of very low carb or intermittent fasting, the glucose curve is going to be higher than it would have been and stay higher for longer than if they were adhering to a normal glucose-rich diet. It's because there's such a fuel shift. The body's become so used to fat burning that when you just load it with glucose, which it has not been relying on, it takes a little longer for it to metabolize that glucose. So a cyclical ketogenic diet enables the body to continue to use that glucose. But again, I'm not advocating that because the cynic could say, well, so what? If I'm not burning glucose, then it's not a problem. Absolutely right. The only reason to be mindful of that is if someone has to go into the doctor's office and actually do a glucose tolerance test, if they've been adhering to a ketogenic diet long-term, they might fail the test, even though they're perfectly metabolically healthy. They just haven't been burning glucose. And so you need to kind of prime that sugar-burning pump, a couple days ahead of time and start consuming glucose. That would be the only real defense of a cyclical ketogenic diet. That is not my reason. My reason for cyclical is just pragmatic.
Sure.
It's just, if when my kid, like tonight, my 7-year-old boy is making dinner for the family, he loves making spaghetti and meatballs. Actually, in that case, I don't eat much of the spaghetti and I just eat the meatballs so I can make it easy. But last week, my 9-year-old daughter made grilled cheese sandwiches. I'm not gonna pick the cheese off the grilled cheese sandwich and lick my lips and say, "Oh, Daddy loves your sandwich." No, I'm gonna eat the bloody sandwich. So for me, it's just pragmatic. If someone needed to justify it health-wise, I don't know of the evidence to do that, but I get it.
Right. So pulling back a little bit to this metabolic flexibility piece and giving people some actionable stuff. So what are the best ways for the people to check if they're metabolically flexible? So like, is there a range of morning glucose levels? The other thing that I want you to speak to, just kind of as an adjunct to that, is when you're testing gas exchange with the metabolic cart to determine if people are metabolizing fat or carbohydrate. Can you just talk about, because they're measuring oxygen and CO2. So I'm curious if we can draw a correlation there with
you absolutely
CO2
can.
tolerance.
Yeah, so if someone has, in fact, even with metabolic flexibility, if someone has access to that kind of little metabolic cart, and there are, I call it a cart because that's how it was when I was a grad student in the exercise physiology lab, almost 20 years ago. In fact, 20 years ago. nowadays it's like a little device. It's just incredible how the technology has shrunk this. So if you have one of these mechanisms to track your gases, you can absolutely determine whether you're metabolically flexible. And it's just pretty much what I mentioned earlier. You eat a meal, you're going to notice that your respiratory quotient or your respiratory exchange ratio, however it's kind of telling it, it's going to tell you that when you eat a meal, you're in sugar burning mode. After about 4 or so hours, you should be fasted because insulin has come down, and insulin is what defines a fed or a fasted state. And you should start to see this shift where sugar burning starts to diminish and fat burning starts to come online. So
what is it actually measuring, though? That's what I wanted you to get at. So, like, is it measuring amount of excreted CO2 versus oxygen? Like,
that's exactly what it's measuring.
So, if you could explain what is indicative of what, if you're familiar.
Yeah, I am. So, when someone is burning more carbohydrate, there is relatively, I want to make sure I get this right, there's relatively more CO2 produced compared with oxygen consumed. And so that ends up, the ratio is such that ends up pushing it higher to 1 as this ratio, as it's measured. The CO2 produced versus the oxygen consumed. In contrast, when someone is fat burning, that is so much more of an oxidative or mitochondrial heavy process. And when the mitochondria need energy, they need oxygen. You can't really think of it as burning. You just think of, you're going to feed a flame. You got to have oxygen available to feed that fire. That's what happens when someone is fat burning. And so that ratio, there's more oxygen being kept by the body relative to the amount of CO2. So that ratio of CO2 to oxygen starts to go down. And so someone would start to see that ratio, at least in a laboratory setting. I don't know how these devices would measure it. Their respiratory exchange ratio starts to go down towards, typically it's 0.7. And so 0.7 is considered like pure fat burning. 1 is considered pure glucose burning. And some people can actually go above that when they're going to maximal effort because, well, you push it a little beyond. So that's it. That ratio and the device's ability to determine what fuel you're using is based on that ratio of CO2 exhaled versus the amount of oxygen that is consumed. And because fat burning needs more oxygen than just glycolysis, than just sugar use or glucose use, that ratio is shifted to be a little lower.
I'm just trying to draw the correlation in my mind, and I don't understand it well enough between like CO2 tolerance and these respiratory exchange quotients.
Yeah. So with CO2 tolerance, I don't know how. I'd need to sit back and think, and I don't want to embarrass myself by trying to do it on the fly here because I'm sure I'd put my foot in my mouth. I'm not sure. I don't know.
It's okay. So then with respect to metabolic flexibility, the other question was just, how do people know? Like, so obviously how quick, if we can just measure our blood glucose, 3 and 4 hours after, that would make sense. But is there a resting blood glucose that you think is ideal? Is there a range you want to be under? I know like the typical American guidelines, and I always think those are pretty subjective at best.
Yeah. So you know what though? It's interesting because fasting glucose levels, the more I see people playing around with their diet, the more I see that some people just run a little high. Some people just are always in the low hundreds, and they are the fittest, healthiest people I've ever met. And I think it is, to your point, it's sometimes difficult to try to fit all of the diversity of humans into these nice, neat cutoffs that clinical practice tries to create. So fasting glucose probably isn't the best. A dynamic glucose is going to be one step better, where if the person eats a glucose-rich meal, within about 2 hours, I think they want their glucose levels to be back down below into the low hundreds. And that's evidence that they've burned through that glucose well, and there's going to be this typical kind of fuel shift. That's if someone is measuring their glucose. I would also say that a non-blood metric might be 2 things. One, does the person have chronically elevated blood pressure? If so, one, actually, that could be that they're just poor sleepers as well, because that very much influences blood pressure. But often in someone with clinically diagnosed hypertension, almost always that is a sign of hyperinsulinemia or elevated insulin. And when insulin is elevated, the body is stuck in sugar burning mode. And then the second aspect of that would be looking at how much fat they have, or how good the fat is on their body. And the simple measurement for that is measure the biggest part around the waist, the fattest part around the waist, times that by 2, and it should be less than the height of the person. If the waist circumference times 2 is smaller than the person's height, that suggests that their fat storage is good. And I say that because insulin resistance likely in most people starts at the fat cell, and that's a whole other topic, but it's basically, are your fat cells, fat tissue can grow through 2 ways. And I don't want us to get into it unless you want to, so you'll pull us back in if you want it. But if it's growing in this bad way, that'll typically be reflected through this elevated waist circumference in particular, and that will be a number when it's times 2, when it's doubled, that would be higher than height. So basically, waist circumference times 2 versus height is a way of just kind of getting a very poor man's version.
I'd love to talk. That's great, but I'd love to talk about the good versus bad fat. That's an interesting. Yeah. I've never heard anybody refer to it that way before.
Oh yeah, it's fascinating. In fact, this Ben, you'll pardon me for mentioning, plugging my book. I go into this, so I've written a book. It's Why We Get Sick. Anyone who's interested, please order it.
June 20th is it coming out?
No, July 21. So
July 21.
July 21. It's available for pre-order now. Just got word that the audiobook will happen as well. So anyway, I go into this in a lot of detail in the book, because the book is essentially in Why We Get Sick. It's what is insulin resistance? Why does it matter? What are the diseases that come from it? And how do we get it? And then what to do about it? And we can come back to that kind of last happy ending later.
Make sure you write the follow-up, how to get healthy.
Yeah, I know. Yeah. Well, that is kind of the last part about the book. It's kind of how to address this insulin resistance and its relevance to chronic disease. But fat cells are usually and probably where insulin resistance starts. So basically, to back it up, when someone is eating a diet that is putting the body in a caloric and energetic surplus, the body needs to account for that. And in some instances, it can increase metabolic rate to just spill off. That very much happens to try to account for this increased energy consumption. But if insulin is high, the body is not going to waste energy. Insulin abhors energy wasting. And let me sort of even mention that in the paradigm I brought up earlier. Earlier, I said ketones stimulate the fat tissue to waste energy. And that's what's happening. In contrast, we published this paper last year. Insulin does the opposite. So ketones stimulate energy wasting in fat cells. Ketones stimulate energy sparing. And so the mitochondria are much more miserly with how they use energy.
Insulin, you said ketones again, but insulin.
Sorry, yeah.
Okay.
So ketones induce wasting. Insulin induces the sparing. It wants to miserly use the energy. So if insulin is high chronically, it's going to want the body to keep its fat very, very well protected and even grow it. So high insulin combined with sufficient calories to support that. Those are two of the critical pieces here. Now, when the fat tissue is being stimulated to grow, it can grow through 2 ways. And this is also genetic, and it's also dietary component, a dietary angle, including what types of fats the person is eating, oddly enough. And we can come back to that. Mm-hmm. So the healthy way of getting fat, and this might seem like an oxymoron, but we know that there are people who are very overweight, and yet based on their blood markers, they're okay. Now, I'm not saying there's this, I think it's extremely uncommon that someone's going to be fat and healthy. And there's a lot of talk in certain circles to say, oh yeah, it's good, it's possible. I don't think it really is. It's just really a matter of how sick are you from that fat tissue. So let's just kind of take it on the sort of good fat version, which is you're getting fat and you're maintaining your health as well as you can. That happens when fat cells are hyperplastic. So the fat cells are multiplying. So the fat cell gets a little big and then it divides. It gets a little big and it divides. And so we're actually making more fat cells. And at no point is any one fat cell too big. And so they have ample blood flow. There's plenty of capillary flow around these little fat cells. So they're getting all they need. They're getting off their CO2 and maybe a little bit of lactate. They're pulling in oxygen as little as they need. And indeed, it is very little because their metabolic rate is so low. But nevertheless, hyperplastic fat tissue is healthy fat tissue. And that's typically when someone has very jiggly, rolling type of fat. It's dangling over their belt and it's a couple rolls. It's very loose, jiggly fat. That is typically hyperplastic. And indeed, their blood pressure can be very normal. Their glucose can be normal. Even their insulin is going to fall within close to a normal range. In contrast, a sick way of getting fat is through hypertrophy. Hypertrophic fat growth is when the fat cell number is set. And this is by far the more common way of getting fat. Fat cell number is typically set at the end of puberty. The moment the person's entering adulthood, which is commonly late teens in girls and even early 20s in men. That might seem late. People think puberty's done. No. If you're a dude and you didn't stop growing until 22, that's when puberty ended. So nevertheless, whenever puberty ends, that's typically the number of fat cells is set. Typically, we can push it up a little higher. But nevertheless, the fat cell will grow. And it grows to such a dimension, indeed multiples more than the other type of fat cells. It grows 4 or 5 times more. Now blood flow becomes restrictive to these fat cells. The cell itself is so big that the entirety of the cell cannot be adequately perfused with blood. It cannot access the blood and exchange everything that it needs to exchange, nutrients and gases. That fat cell becomes sick and sick, that's a silly way to say it. It becomes insulin resistant. And this is actually adaptive. So earlier I mentioned I was interested in how the body adapts to obesity. By becoming insulin resistant, this fat cell is limiting its growth. It's essentially telling insulin, you want me to continue to grow, but I can't. I'm done growing. And so I'm going to stop responding to insulin. And when a fat cell becomes insulin resistant, it starts leaking fat. Now, it ends up being sort of net zero. It still is taking in some fat in response to insulin, but insulin can't stop it from leaking fat because insulin does that. Insulin inhibits a fat cell from breaking fat. It inhibits polymerase. So this resistant fat cell is leaking fat into the bloodstream, and that usually goes right to the liver. And then second, it's releasing pro-inflammatory proteins called cytokines. And this combination of elevated free fatty acids and elevated inflammation then basically starts to spill that insulin resistance through the rest of the body, namely the liver and then the muscle. And when the muscle becomes insulin resistant, you're right at the doorstep of type 2 diabetes because muscle is the biggest sink for glucose. And insulin facilitates that glucose uptake from the blood into the muscle. And if the muscle's insulin resistant, it can't pull in glucose as well anymore. And again, it's the biggest deposit of glucose in the blood from the blood. And now the glucose levels start to climb.
Is there some, blood markers, or is it just simple as looking at resting insulin and cytokine levels in somebody's blood? Like, how do I know if I've got this? Yeah, is that kind of
you could absolutely do that. Now, but I would one step back. Looking at the waist circumference doubled versus height is kind of the poor man's method of looking at that, combined with blood pressure. Hypertension is one of the most common signs of insulin resistance. But if someone has access to blood measures, I can't cite the specifics on all the cytokine levels, but C-reactive protein is a commonly measured one. Almost anyone who's had a blood test recently probably had C-reactive protein measured. That's a good indicator of inflammation. And then fasting insulin, my personal cutoff is you want to see that at 6 microunits per mil or less.
So from the sounds of what you're putting together, it sounds like you may have an argument that suggests that someone might be able to get away eating more calories provided it's a fat-rich, fat-predominant diet rather than someone who has a carbohydrate/sugar-rich diet. Any perspective on that?
Absolutely, I have a perspective. Yeah, so there was a study just published, and it is so unfortunate how they phrased this. It was like a plant-based whole food diet controls appetite better than an animal-based ketogenic diet or low carbohydrate diet. And so what this study found was that as people shifted, like 2 weeks on one diet, plant-based, high carb, 2 weeks on animal-based, low carb, 2 weeks difference between them, they found that body weight was similar across the board in these two diets, but the plant-based high carb, low fat diet, they ate 600 calories a day fewer than the animal-based low carb ketogenic diet. And so let me flip that around. The ketogenic diet phase, they ate 600 calories a day more, and yet they weighed the same. So this, I think, comes, and David Ludwig out of Harvard published a paper last year, I think, where they found that metabolic rate can shift up to 270 calories per day based on shifting the macronutrients. If they set protein at about 20%, then the rest of it, they just shifted between carbs and fat. And in the highest carb diet version of this, metabolic rate slowed by about 100 calories per day. And on the lowest carb, highest fat version of this, metabolic rate went up 170 calories a day from baseline. So the net swing there was almost 300 calories per day. And this is something that's been known for decades. And it might be relevant with our study that we're doing now, which is namely ketones. If ketones are online, so to speak, if ketones are elevated, then metabolic rate is going to be higher.
It's very interesting, because if you look at the thermic effect of food, obviously we know protein being the highest.
Yep.
It's been suggested that fat actually has the least, is it not?
Yeah, so I believe fat and glucose are pretty much on par. So fat's effect is not going to be through a thermic effect of food. It's going to be more that fat has the least effect on insulin.
Right.
That's a little speculation. So it's not the thermic effect. You're right. Protein is significantly higher than the rest. All the more reason to eat more protein. But you know what, Ben? As an aside, I think it's unjust to even consider protein a fuel. Protein isn't a fuel. Protein is a building block. I don't think it should even be counted as calories when we look at the labels on food. It is an extreme situation when someone is using protein for energy. It is very uncommon. Even in a fasted state, much of that new glucose, the gluconeogenesis, most of it's coming from lactate, not from amino acids, from protein, but that is admittedly an aside. So yeah, the thermic effect of food aside, fat and carbohydrate appear to be pretty similar. It's really more what they do to insulin, because insulin both dictates fuel use and metabolic rate.
Do you ever consider the psychological implications of a ketogenic diet? So I have a lot of clients who started to create, and this seems to be pretty ubiquitous across the keto community, they start to create this association where fat is almost like free. As long as it doesn't spike my blood sugar, I can just kind of eat freely, whereas they almost demonize sugar and carbohydrate. And I find a lot of people gaining fat from a ketogenic diet because they are just like, oh, it's not going to spike my blood sugar, I'm good. Is that a healthy perspective? Like, how much freedom do they have as long as they don't spike their blood sugar?
Yeah. So that is an overly simplified, overly simple perspective that some people I think do have. My philosophy is also perhaps overly simple, which is on the front end of a ketogenic diet, I think a person can look at it that way, that typically their appetite is sufficiently controlled. Ideally, that calories be damned, just you scrutinize your carbohydrates, focusing on the most kind of raw sources as possible for those, say, 50 grams per day, and then be as liberal as you want with fat and protein. But I think it is so important to keep those two together. Fat and protein in nature come together. Mm-hmm. It is only with a little bit of processing, and I do even mean minimally processing. Pure fat is uncommon, but our ancestors have done it, and I think for good reason in certain instances. But when I hear people being very liberal with fat, I think that's okay as long as it is sort of ancestral fat, and that is animal fats and fruit fats. And the fruit fats are coconuts, avocados, olives. Those are fats that we as a species have been eating since time immemorial, because our ancestors, with whatever limited technology they had, if they wanted to get fat from an olive, although they never would have gotten it from avocados because I don't think they really grew the way they do now, all they would have done is just squish it. The same with coconut, I believe. You take the coconut flesh and you compress it and you're going to get an oil from it. We could have done that. All we needed was a lever, or in the case of an olive, just our own body mass would have been enough. So those are ancestral fats. We are adapted very, very well to eating them. But overwhelmingly, fat should come with protein. That is how God or nature, whatever we want to ascribe to, that's how these foods were built. Fat and protein come together. In fact, Ben, talking about protein, there's almost no source of protein and carbohydrate, and almost no natural sources of carbohydrate and fat, except for the fatty fruits, which are actually more fiber and fat. In nature, carbohydrate comes alone. Fat and protein come together. I think there's something important there. And even if we look at it from the perspective of the muscle, I'm a middle-aged guy who wants to keep whatever muscle I can. There was a study published a few years ago finding that if you gave people, this was looking in men, and they were looking at the rate at which the muscle can create new protein, what's called muscle protein synthesis. If you gave these guys pure protein, there was a significant increase in muscle protein synthesis. Now, mind you, well, in fact, I'll describe it this way. Pure protein has an increase. If you stack carbohydrate on that protein, it didn't go up any more than just the protein alone. So that does touch on this idea of guys wanting to take a carbohydrate-rich meal with their protein. There's no justification from the perspective of the muscle, at least, and the muscle protein synthesis. In contrast, when they stacked on fat to that protein in a 1-to-1 ratio, like you see in an egg and with most cuts of meat, and by 1-to-1, I mean by mass, not by calorie. So it's a 1-to-1 of equal amount of grams of protein per grams of fat. That mix of stacking protein and fat increased muscle protein synthesis higher than the protein alone did. And so even there, from the perspective of muscle physiology, I think we see some of the wisdom in nature providing protein and fat together. That's just how they come. And one last point, those are the only two essential macronutrients, essential amino acids, essential fats. All the more reason for me to say, don't eat, I'm not saying don't eat any carbohydrates, but just be smart about them. They are not essential in the human diet. Now, it's not to say we don't eat them, but don't let that be the bulk of all of your calories. Let the bulk of the calories be what you actually need, what you physiologically need, these fats and these proteins. And from my perspective, they're also the ones that have the least effect on insulin, all the more reason to enjoy them.
Sure. Any consideration then around protein's effect on insulin? So obviously, if you're an advocate of a high protein, it sounds like you're saying eat protein freely.
Yeah.
And freely can be sometimes correlated with an insulin response.
Yep, you're absolutely right. Yeah, so anyone who's more curious about this after this, by all means, go onto YouTube and type in Bikman and protein. I think that would probably be one of the first hits. I spoke about this a couple years ago because kind of relevant to what we're talking about now. When I was first getting into the kind of low-carb community, because that was a bit of a transition for me as a scientist to appreciate its efficacy and its role in good health. Not that I claim it's the only way to do it. I don't. I just think it's arguably the best for insulin resistance. But nevertheless, I heard people, in fact, I saw people like literally drinking MCT oil. And I thought that is a bizarre way to eat. It is an unnatural thing to do, to just be drinking oil. And it was because of people saying, oh, well, I can't eat protein. It'll kick me out of ketosis. Who cares if it kicks you out of ketosis? If it does, it is because there's an insulin spike, and let the insulin tell the body what to do with that protein, which is build something from it, because insulin wants to build. And so lest anyone ever think I'm just waging war on insulin, I'm not. It is an essential hormone. We need it. It is a terrible disease if you don't have any insulin. We need insulin, and part of its role is to build. It is anabolic. Now, the degree to which it's totally anabolic at the muscle is somewhat debatable. It's certainly nothing in the order of what growth hormone is, but even still, protein can have an insulin effect, absolutely. And much of that insulin effect, the magnitude of that insulin effect, very much depends on the underlying glycemia or glucose. So my point is, if someone is eating protein in a fasted or a ketogenic state, the insulin effect is going to be less. And this was a study done in dogs. I don't know of a comparable study in humans, but I would defend it by saying dogs actually have one of the closest digestive systems to humans as any other animal, oddly enough, even more than primates do to humans. But nevertheless, Protein alone is going to have an insulin effect, modest if it's in the context of low glucose. If you combine the protein with glucose, you will amplify that insulin response much higher. Or if someone has underlying hyperglycemia, you are going to amplify the insulin response to the protein. But even then, though, Ben, I would still defend protein. As much as I look at nutrition through the lens of insulin, and I believe I'm justified in doing that, don't worry about the protein, especially if it's coming from natural sources, and especially if it's coming with that mix of fat, that magical 1-to-1 by mass ratio of fat to protein.
Right. Any consideration on genetic variances in that case? So I know some people who, like you sit down to eat a 10-ounce steak and I sit down to eat a 10-ounce steak. Your blood sugar may go to 120, mine may go to 95. Mm-hmm. And have you ever heard of or explored a genetic response, or do you think it's mostly to do with the state of the autonomic nervous system, the state of the glucose tolerance?
Yeah, that is a great point. You're absolutely right. I've heard people say the same thing, and I don't really have a lot of thought on it.
Yeah, completely understandable. It's definitely, you're definitely an expert in insulin. There's so many different facets of implications in metabolism. It's endless, absolutely endless. Tell us a little bit about your book. So you've told us a lot of what's in there, but I'd love to talk a little bit more about what maybe we haven't talked about.
Yeah. So thanks for the opportunity. Yeah, the book was kind of people always say this, and I mean it. It was really sort of a labor of love, where about 5 years ago, I taught a class here at BYU, at my university. And this wasn't a typical class to undergraduates. This was a class for the public. So every summer, BYU sort of opens the campus to allow experts, faculty or not, to teach a week-long series to just anyone who wants to sign up. And so this was about 5 years ago, I think. I was looking at my insulin resistance stuff, and I thought, this would be a fun opportunity to kind of try to convey some of this to a non-student audience, because students never really care; they just want to get an A. And so I thought, I wonder if I can convey this idea to just non-student audience well. And the response was really positive. And at the end of this week, I had dozens of people saying, "Hey, can we go get your book? Is your book at the university bookstore for sale?" And that was me thinking I should probably get a book, but for two reasons. One selfish and one altruistic. And the selfish reason is, as a professor, I'm eager to, bump up my income any way I can. Professor, it is a wonderful job to get paid to just kind of be curious as a professor scientist, but it doesn't pay very well. So I thought, would this be a nice way to supplement the income? And that remains to be seen. But second, it is a way to just really convey some of what I know in long form. And so that was the justification for the book. And it is essentially broken up, as I mentioned it earlier. The first part of the book talks about why insulin resistance matters, or how we get it and how common it is, because it is shockingly common. And I even kind of go through a little quiz of, do you think you might have it? Go through this yes or no question, this quiz, yes or no questions. And then the second part is why it matters, which is highlighting all of the diseases that are derivative from insulin resistance. And it is shocking. Heart disease, Alzheimer's disease, fatty liver disease, infertility in men and women, and more and more and more. And then the last part is the happy ending. Up until that point, it's sort of reading like a horror story. But the happy ending is that the third part of the book, which is that this problem is extremely changeable. You can have profound insulin resistance, and you can literally start to turn it around within just a couple of days. And it isn't, someone might be hearing this and think, oh, it's just going to be him spouting off on a ketogenic diet. I definitely do. But I'm diplomatic and even objective enough to highlight things that are not ketogenic diets, including intermittent fasting, including plant-based low-fat diets, which in principle I sort of struggle with. I don't believe it's sustainable for human health long term. But you can take these two extremes, or take someone who's vegan, which I confess I'm very opposed to, or even pure carnivore. And on this spectrum of total extremes, what they have in common, ideally, is that they've both avoided fake foods. these packaged little foods that you can rip open, or loaves of bread or cereal, whatever it may be. That's what they have in common, that they're avoiding those foods. And so even at these extreme ends, you can improve your insulin resistance. And so that's the book, again, available for pre-order anywhere. But I will say, let me elaborate a little more on that last part, on the solutions part. When someone starts to adhere to some key principles, they do encounter some hurdles. And so I mentioned 3 principles in the book. I basically outline my 3 pillars for effectively controlling insulin resistance. And then I would just say being healthy in general. And it is 1, control carbohydrates. That does not mean don't eat any of them. It just means be smart about it, or be starch smart. Focus on fruits and vegetables. Focus less on processed grain foods in particular, because they have substantial insulin effects. The second one is prioritize protein. Make sure you get enough protein. And the best sources of protein are animal sources. As controversial as that is, there is no controversy in the science. Animal-based protein, in particular whey and egg white, are the best proteins for humans. Also, as an aside, and I'm going to try to remember to come back to the topic, one of the problems with plant proteins, Ben, that people don't appreciate, other than the amino acid profile not being optimal or absorbable, when you take a vegetable that is extremely deficient or very, very low in protein, if you want to get 1 serving of protein from, say, peas, you need a lot of peas to do that. You've got to concentrate it and concentrate it and concentrate it, and then you've gotten 1 serving of protein. That's what you want to get from all this protein processing from the pea. Unfortunately, you also get stuff you don't want. And this has been published. You get lead and arsenic. There are these metals that your body's going to struggle to deal with for years when you're getting and thinking you're doing your body a favor. But the problem is companies are incentivized to use plant protein because 2 reasons. 1, it is cheap. Plant protein is much cheaper than animal protein. And 2, it lets them virtue signal. They can brag about how these are plant-based proteins. And the average person is going to think, oh, that's good. Plants are really healthy, not knowing that these plant amino acids, these plant-derived amino acids come with stuff you don't want. They come with some villains. So anyway, that second pillar was prioritize protein, make sure you're getting enough. And the third pillar is fill the remaining of the calories with fat. Emphasis, again, on what we mentioned earlier, fat and protein are typically going to come together. So those are the 3 pillars: control carbohydrates, prioritize protein, fuel with fat. However, when someone starts, one of the benefits of that is you immediately start cutting out convenient foods. Convenience foods typically don't follow those 3 rules. And so when someone starts following those pillars, it can become a challenge to have the time and the knowledge to prepare these perfectly packaged foods. With that in mind, if you won't mind me mentioning, a couple of my brothers and I, looking at this problem, we addressed it. And so we actually made a shake. And Ben, I'd gotten your blessing ahead of time. Anyone who's listening and wants to give it a try, please appreciate it. I'm not trying to be too heavy-handed here. Anyone can address these 3 pillars through real food. And if a person thinks they can do it, all the more do it. All power to you, do it. For those who are time crunched or enjoy shakes and enjoy the convenience of it, go to this website, Get Health, and that's Get HLTH, HLTH.com, gethealth.com, and again, that's HLTH. And just look at the shake, read the justification for it, look at the ingredients, and then enter at checkout, enter Muscle 10, and that's just a coupon for Ben for your podcast, and you can get 10% off the order. So anyway, that aspect of me mentioning the shake.
I'll give you a shout out on that. So first thing, speaking to the pea protein, that's been proven that there's no pea proteins that have acceptable amounts of lead in the entire country. They don't exist yet. And as far as your products, you send them to me. I think they're absolutely fantastic. The ingredients are so well thought out. Just like everything you speak about, they're authentic and they're fantastic and not overly flavored, which I like. They didn't taste artificial. So I highly suggest people take advantage of that generous offer. So thank you, Dr. Bikman. Thank you for putting out that product. I mean, truthfully, it's nice to have someone who's got a little bit of just authenticity and putting out a product that's actually valuable. So we've got a few questions coming in here from our audience. If you don't mind spending just 2 or 3 minutes answering some questions.
Yep.
Can you explain adaptive glucose sparing?
Yeah, so adaptive glucose sparing is actually another way of describing what I mentioned earlier with the glucose intolerance that you get from a fasted or a ketogenic diet. Adaptive glucose sparing is essentially the body starts to turn off its glucose use or diminish it or dampen it. That's the best word, to dampen its glucose use because there's so little glucose coming in. Now, earlier I had said dietary carbohydrates are not essential. That is true. I will defend that till the end of time. That is not the same as saying glucose isn't essential in human health. It is. We need it. There are certain cells that absolutely demand it. And so thank heavens that the liver creates everything that we need. But when the liver has to be creating glucose to fuel the body's glucose needs, the body goes very miserly with its glucose. And that's, of course, happening because we're not eating any. So adaptive glucose sparing is synonymous with a dietary glucose intolerance. So that's what I said earlier. Someone's ketogenic diet, they eat a big glucose load. It takes a lot longer for the glucose to come because the body is used to, as Betty mentions it, is used to sparing the glucose. It needs to use very little of it or use it as efficiently as possible in order to make sure there's enough for the cells that actually need it.
Awesome. We're going to go to this one. Is there any relation between insulin and Crohn's disease?
Yeah, there is, but it's not. In fact, I go into this into the book in a gut health section. There's not a lot other than correlation. I am unaware of a mechanism to explain it, but what the relationship is probably built on is that someone has Crohn's disease, which is autoimmune, and then when the Crohn's disease is active, they are insulin resistant during that phase. Now, I will say I've known people with Crohn's disease who find that one of their main triggers for this autoimmunity is grains. And typically with Flavio asking this question, I bet he's already known this. This is one of the first things when someone starts going on an elimination diet, grains are right near the first things they start to cut. And they happen to also be pretty much the biggest insulin spike.
Yeah, it seems like vegetables, anything with lectins and oxalates tends to flare up Crohn's quite a. I mean, histamine levels as well is a huge one.
Yeah, that's right. And mind you, and Ben, interestingly, right, I never know anyone who has those kinds of responses to meat.
Never.
No, never.
No. So this is a question that you kind of started touching on, that the type of fat people eat matters. And I know you spoke about this a little bit. Now, one thing, if you can answer this question, but I'd be curious about your thoughts around like the phospholipid bilayer composition and how adaptable that is, and does it implicate in someone's ability to burn fat?
Yeah, excellent. In fact, I'm thrilled to get this question because I did mean to kind of come back to it. I sort of teased it earlier when we were talking about fat cells growing through hyperplasia, which is healthier, versus hypertrophy, which is a more dangerous or at least insulin resistance inducing state. Seed oils and seed oil metabolites in particular appear to be very relevant to this process. Now, let me not throw all seeds or nuts under the bus. Really, we need to focus on the omega-6 polyunsaturated fat, linoleic acid. Now, it's like most.
When you say focus, you mean remove.
Yeah, so that's the one to be very careful on. Yes, that's right. That's what I mean. We need to scrutinize linoleic acid, which is an omega-6 polyunsaturated fat. We eat so it's shocking, Ben, when you look at the previous century of eating, at least in the US, and the rest of the world is certainly very much like this, soybean oil went from being completely non-existent in the diet to being the single most commonly consumed source of fat in our diet. So we eat more soybean oil. We eat more fat from soybean oil than any other source of any other food we eat. And soybean oil and its similar molecules similar oils like canola oil or like vegetable oil in general. That's actually usually soybean oil. In fact, vegetable oil is not vegetables. It's seed oil. Vegetables don't make oils. But these industrial oils are enriched in this omega-6 linoleic acid. Now, linoleic acid is an essential fat, and that's fine because you get it in almost every food. So it is necessary, but we eat, I think it's like 56,000 times more linoleic acid than we did a century ago. So this is a fat that went from 0 to 60
Huge.
in very little time. And so those refined seed oils are something to be careful with, but nuts and other seeds like chia or flax actually generally have fairly lower levels of linoleic acid and higher levels of others. And chia and flax in particular have higher amounts of omega-3, although it is the lesser usable kind. It's alpha linoleic acid rather than EPA and DHA. So for brain health, that it's not going to constitute those big lipids like you mentioned in membranes, but it is going to the alpha linolenic acid, the omega-3 from seed oil, from flax and chia seed. Those are actually among the highest burned fats in the body. So they're actually, that alpha linoleic acid is the most ketogenic of all fats in the body because it's just burned so rapidly. But nevertheless, industrial seed oils like you get from sunflower oil or soybean oil, those definitely play a part in multiple diseases, but especially in the context of a fat cell not growing healthy, being stuck in hypertrophy mode, which is, of course, then going to cause insulin resistance.
Amazing, Dr. Bikman. Ladies and gentlemen, thank you so much for listening, tuning in. Gethealth.com, GETHLTH.com. You can use the code MUSCLE10. And also, we're also going to pick up your book. Everyone should head over to Instagram and follow Dr. Benjamin Bikman. Thank you so much for being here. It's always an absolute pleasure.
Oh, my pleasure, Ben. Really, thanks again for the invitation.
Thank you for always listening all the way through the Muscle Intelligence podcast. I do my best to curate, bringing you intelligence for your life, body, mind, and soul, and I hope you've enjoyed another incredibly eye-opening conversation with Dr. Ben Bikman. Head over to Amazon and pick up his book now. You can pre-order Why We Get Sick by Dr. Benjamin Bikman. And if you're someone who likes to help other people and you want to see people in your life get healthy and get fit and get strong, this is a really great podcast to share with family and friends so they can start to understand how to make decisions around nutrition. I think a lot of us don't understand how insulin impacts our body or how inflammation is impacting our body. And there's this huge movement right now around if it fits your macros. And I think it's the most misguided information, or at least poorly guided. It certainly has merit in some populations, but in 90% of the population, it's just not a good idea. So listening to someone like Dr. Benjamin speak is eye-opening. I think a lot of your friends and family would appreciate this information, and I would appreciate a 5-star review on iTunes. If you haven't already subscribed to the podcast, do that now. I've got a whole new format coming up for you guys really, really soon to give you more actionable information that you can apply right now to your body, mind, and soul. One more shout out to our podcast sponsors, Blue Blocks, because they're awesome. We're super grateful for them. Blueblocks.com/muscle intelligence, BLUBLOX.com/muscle intelligence. Use the code MUSCLE. Have a great day. Live your greatest life in a body that you love.
Thank you so much for tuning into Muscle Intelligence. If you enjoyed today's episode, please be sure to share it with at least one person you know. Make sure you're subscribed so you never miss an episode. This podcast is for information purposes only. The statements and views on this podcast are not medical advice. This podcast, including Ben Pakulski and the producers, disclaim responsibility for any possible adverse effects from the use of information contained herein. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. This podcast may contain paid endorsements or advertisements for products or services. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. If you think you have a medical problem, consult a licensed physician.